Hello and Assalamu alaikum. Today's topic is about the turning effects of forces and moment. The subtopics are center of gravity, center of mass, stability, moment of force, turning effect, and equilibrium. सबसे पहले let's talk about the difference between center of gravity and the center of mass. And then it would help us talk about the ideas of stability, pivots, turning effects, and equilibrium. So सबसे पहले let's define what center of mass होता क्या है और center of gravity होता क्या है और ये दोनों एक दूसरे से different क्या है. Center of mass is a point where mass distribution is considered to be uniform in all directions. ठीक है. एक अगर एप्पल है तो एक एप्पल का सेंटर ऑफ मास वो जगह होगी जहां से उसका जितना भी अमाउंट ऑफ मैटर पैक्ड है वो इक्वली डिस्ट्रीब्यूटेड होगा in all directions. Now, because an apple is not of a uniform shape, तो अगर हम एक circle का center of mass लेते हैं तो it would most definitely be its midpoint. Now, the center of gravity is somehow different in the sense that it is the point where weight is evenly distributed. ठीक है, तो ऊपर हमने mass की बात की, इधर weight is evenly distributed. Now, when you're in a uniform gravitational field, which I hope you will learn more about from our videos on gravitation, कि एक uniform gravitational field होता क्या है, तो center of mass or center of weight है, it would pretty much be the same. However, things are different when you're not in a uniform gravitational field. A center of gravity is so a point from which the weight of the object may be considered to act. All of the weight of an object may be considered to act. It is very easy to define, to identify a center of gravity of any object. For example, the center of gravity of a uniform triangle would most definitely be the center point of its line of symmetry, which would be somewhere around here. If I had done this for an oval shape, it would be this point right here. If I had done this for, let's say, a parallelogram, then the center of gravity would be the intersection point of these two diagonals. It would be some point here. Then अगर ये दोनों चीजें सेम है तो ये डिफरेंट कैसे है? Difference is when the field is not uniform. The center of gravity is in this way dependent on the gravitational field. Dependent on the gravitational field. How? We'll discuss further. लेकिन अभी के लिए आप याद रखें कि it is dependent on the gravitational field, and obviously when we say the gravitational field, we're talking about the forces of gravity that are acting on an object. Whereas center of mass, it's not dependent on the gravitational field in any way. ठीक है? Now, let's take an example. अगर एक ऑब्जेक्ट स्पेस में है और वो एक let's say it's between two different bodies. Let's say we have a little ball over here. तो अगर वो सन की तरफ ज़्यादा है उसका जो center of gravity है it would dislocate itself to a point where it's more closer to the sun, because sun का gravitational pull जो है on this object would be greater. However, the center of mass would still remain close to its geometric center, which would be the same point. So this is the difference between the center of gravity and the center of mass. Now let's talk about how this affects the stability of an object, the center of gravity, and the center of mass. Now, obviously, a both obviously term and stability refers to how stable an object is. For example, if we have a cone right here, it would not be very stable. अगर इसको हल्का से इधर wind का push आता है, it would topple over. Whereas if we had a rectangular cube, a rectangular shape, on a table, it would be very stable. It takes a lot of effort to topple it, topple it over onto the other side. So the position of the center of gravity of the cone is outside of its body, which makes it topple over. However, position of the center of gravity of the cube is very low and still inside. First point is, as low as you can keep the center of gravity, the more it would be stable. First point तो ये हमारे पास आ गया है. Secondly, about the stability is that you keep the base closer to the ground in the sense के आपकी जो height है वो इतनी ज़्यादा ना हो. For example, in the example of this cone, इसकी जो height है वो बहुत ज़्यादा है and the base is very narrow. This has a very wide base, which makes it extremely stable as compared to the rectangle. So the narrower the base, the higher its center of gravity and the object is more likely to topple over. The wider the base, the lower the center of gravity. This is the other point. Low center of gravity is equals to more stability. Is equals to more stability.